Homework number 26. For question number 1, you'll need to solve this equation by distributing, giving you 2x minus 6 equals 2x plus 5. Do you see it already? Matching variables, but different constants, means you're going to have a special solution. But here's the proof. If I add 6 to both sides, giving me 2x equals 2x plus 11, and then subtract 2x from both sides, I'm going to get nothing on the left and still have 11 on the right. And that statement is false. So there is no solution. For question number 2, you have the option of drawing your answer or typing your answer. If you're drawing your answer, you can move this drawing box around so that you can still see the question. So we're going to write with our finger, or you can use your mouse pad. Negative 8 minus 5x equals 20. Now you can show your inverse operations like this, adding 8 to both sides, and then dividing by negative 5. And then be sure that you carefully write the sign of your answer, right? Because 28 divided by negative 5 is going to be a negative answer. It's going to be 5 with 3/5 left over, or you could use a calculator and get the decimal version. Negative 5.6. At the bottom of the screen, here, you can click Add Drawing. If you want to take it away, you could also type your answer here. Negative 8 minus 5x equals 20. And you could write your plus 8 on both sides with using the spacebar like this if you'd like. Or you can simply just write the answer to what happens after you add 8 to both sides. You would get negative 5x equals 28. And instead of showing that you want to divide by 5, you can just divide by 5 on your calculator and write the answer like this. Typing it in the box, and then you're done. Question number 3 asks you, which one of these 4 graphs has a constant rate of change of 3 degrees Celsius? So that means who goes up 3 and over 1. That's what a constant rate of change is. So when I look here at 20, and then I go up 1 for every 3, that's not right. When I look at the next graph, at my perfect corner points, here, 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 and here, looks like I go up 1 over 1, up 1 over 1, up 1 over 1, and that's not right. For letter C, it looks like I go up 2 over 1, up 2 over 1, and that's not right. So that leaves us to look at option D. If I look at these perfect corner points, it goes up 3 over 1. So that is the right answer. Question number 4 says, a cook uses 2½ cups of flour for every 1 ounce of butter. So for every 1 ounce of butter, we have 2.5 cups of flour. So if I double the butter, 2 ounces of butter, I have to double the flour, 5 cups of flour. So let's see which graph would match up with that. So if I have 1 ounce of butter, that would be in between here, I would need 2½ cups of flour, which is not what I'm seeing on this graph. 1 ounce of butter, 2½ ounces of flour. 2 ounces of butter, 5 cups of flour. So this one's out. Let's take a look at option B. Again, we're looking for this relationship here of 1 ounce of butter is 2½ cups of flour, and that 2 ounces of butter is 5 cups of flour. Again, I'm not seeing that on the graph, so we're going to scroll down again to options C and D. So let's take a look. For every 1 ounce of butter, we need 2½ cups of flour. And for every 2 ounces of butter, we need 5 cups of flour. This looks decent, and so does this one. 1 ounce of butter, 2½ cups of flour, 2 ounces of butter, 5 cups of flour. But this is the main difference. Right down here. What if I have 0 ounces of butter? Well, then that would mean that I would have 0 ounces of flour. And that means D can be the only right answer. Question 5 asks you, what is the equation of the line that's graphed here? Well, it looks like I have a y-intercept of 8. And here's another perfect corner point. And when I count down here, it looks like these boxes go by 2. So 2, 4, 6, 8 boxes down, and 2, 4, 6, 8, 10 boxes to the right. So it looks like I have a rate of change of -8 over 10, and a y-intercept of 8. I know this fraction can be simplified to -4/5. Again, my y-intercept is 8, and my rate of change is -4/5. So I'm looking for -4/5 x plus 8. -4/5 x plus 8. In this one, we're going to do the same thing. So I see here that the y-intercept is -2. So that means these are out. The next thing I see is my line is going uphill. Well, that means that this is out, because that has a negative slope. So that must mean that A is the only right answer. Question 7 asks you, what is the equation of the line that passes through 412 and has a y-intercept of -2? Well, all of these have a y-intercept of -2. So what we need to figure out is what would be the slope. Well, the good news is, to find slope, you need 2 points. Well, right now I only have 1. But this is actually a point, because a y-intercept has a y value of -2, but always has an x value of 0. So now I can use my y2 minus y1 over x2 minus x1 slope formula. So my y values are 2, -2 minus 12. And my x values are going to be 0 minus 4. So that would be -14 over -4, which reduces to -7 over -2, or +7/2, giving me the answer of B. For question 8, you're asked to identify which one is not a function. And when you're looking to see which one is not a function, you're going to focus on the inputs, or the x values. You can never repeat an input with a different output. So as I'm scanning my inputs, I'm looking for one that repeats, right here. And when it does, it has a different output. You can't be paired with +4 and -4 at the same time. So that means letter T is not a function, because every input can only have one output. Question number 9 is the same question. Which one of these tables is not a function? Do you remember the rule? You're looking for an input that repeats, but with a different output. And here it is. The input of 3 repeats with different outputs. Question number 10 is the same question, but without a table. Which one is not a function? So look at your inputs, right? So all of my inputs are unique. If I repeat it, then I wouldn't be a function. So I'm looking for a repeat of -2, 4, or 10. And here it is. If I used the point listed in option B, it would no longer be a function, because we'd have a repeating input of 4 with different outputs. Question 11 asks us which one is a function. Now this one is a little bit harder to see for the repeating inputs. So what we usually do is we use something called the vertical line test. We take a vertical line and we scan it across our graphs. And if we touch a graph in more than one location at the same time, like here on option C, here and here, then it fails the vertical line test. So C is not a function. Neither is B, because it touches here and there. Well, that means that option A passes the vertical line test. Which one of these represents a function? Well, look at those x values. If they repeat, they're not a function. If they repeat, they're not a function. But if they're all unique, then it is a function. Number 13 asks you which one has a greater slope and a greater y-intercept than the function listed here. So, the function listed here has a slope of 9 minus 5 over 1 minus negative 1. And you don't have to use those 2 points. You could also use these 2 points. 17 minus 13 over 5 minus 3. It's the same answer. 4 over 2, or 2. So the table has a slope of 2. And we want an equation that has a greater slope. So A is out. Now what we need to do is figure out the y-intercept. So we're going to use our y equals mx plus b formula to determine that. We know that the slope is 2. So all I have to do is erase the letter m and replace it with a 2. But now I need to erase the letters y and x so I can figure out what the y-intercept is. And all I need to do is replace them with any number I want. So here's a point from the table. If x is 1 and y is 9, I could figure out what b is, because 9 is equal to 2 plus b, which means that b must be 7. So the table here has an equation of y equals 2x plus 7. And we need to have values that are higher than both of those. So this one's out. This one's out because 6.5 and 5.5 are lower than 7, leaving us with the only option, which is B. In this one, they're asking you which function has the least value for the y-intercept. So when we scan down here, we see this has a value of 15. And that's negative 2. So this one's out. Now of B and C, we can see that the y-intercept here is negative 2, but the y-intercept here is negative 3. So that means B is also out. And now, for final choice D, that y-intercept is 2, which is higher than negative 3, and that means that negative 3 is the lowest. For this question, we have a chart of the number of goldfish and the cost, and they want to know which statement describes the rate of change. Remember, rate of change is the change in y over the change in x. So it looks like my y's are going up by 1.5 or 1.50, but my x's are going up by 5. And when I divide this here, I get 0.3 over 1. Don't forget y is the cost, and x is the number of fish. So it's 30 cents per one fish. So the cost is 30 cents each time one goldfish is added. So the answer is A. In this question, the chart shows that Mr. Gibson deposited $500 initially, and then he made some additional deposits as shown here. Which equation models the relationship of the amount deposited over the number of months t? Well, we know from the story that he has an initial deposit of 500, so that's the B value. The only one that has an initial deposit of 500 is option C. Not much work here to do, but we can also notice that this goes up by 1,000 for delta y, and this goes up by 4. and 1,000 divided by 4 is 250. So there's the rate of change. Number 17 shows us the graph of a bicycle club over a period of time. And when they ask you which statement best interprets the graph, you kind of have to notice that first, the time is going and their distance away from their initial location is getting greater. And then right here, their distance doesn't change. But then it starts to go again. So there's a bit of a break in the graph here. So that means that they don't constantly ride the same speed, but they did stop for a rest right here. And we could say this one's wrong because it's not continuously the same amount, and it never decreased. So the only option is B. Number 18 shows us sections of graphs that are different shapes. Some are curved or nonlinear, some are flat or constant, and some are going downhill, decreasing. Let's take a look at the question. Which statement correctly describes the function over a given interval? So let's look at -7 to -4. That would be this section right here. It's not decreasing because my eyes travel up as I'm looking. How about from -4 to +1? It's definitely not increasing because it's remaining flat. How about from +1 to +4? It's increasing? Yes. So that is a true statement. In this graph, they ask you to describe the association between the number of days the food truck is in the same location and how many customers it has. Well, when we look at this graph, it's certainly increasing, and it's following along the pattern of the straight line that I drew. So that means it has a positive linear association. For this one, the classmates' height and shoe size are compared on these scatter plots. They're asking you which one is the most accurate line of best fit. An accurate line of best fit will have points both above and below the line. You'll notice here that most of the points are below, but here the points are scattered up and down. So C is the correct answer. Same question for number 21. What would the line of best fit reveal about this data? Well, as I'm looking at the data, it's certainly increasing, and all of those points are closely related to my line of best fit. So definitely is positive because the line is going uphill. So this is out, and this is out. And since these dots are so close to my imaginary red line, we call that a strong fit. So there is a strong positive relationship between the cost of the rent and the size of the office space. Question number 22 asks you, based on your imaginary line of best fit, what would be a good prediction if Jean were running 2.5 miles? Well, here is 2.5 miles. Now there's no dot along that line, so a best prediction would be somewhere in this area. So we're looking at 10, 20, 30. So it's got to be less than 30, but more than 20. So less than 30, but more than 20. When I look at the options, less than 30, but more than 20, leaves me with only option B. For question 23, if you were to draw your own line of best fit through this data, well, that's pretty good. I can tell already that it should have a negative slope. I don't know what the slope is, but I know it's going to be negative. So that means B is out. Now the next question is, where's the data starting? What's the initial value like? Initial value looks like it might be up here by 6 or 7. So that means that C and D are out, and A is the only logical choice. For question 24, we're going to keep the base the same, and we're going to add the powers together, leaving us with option C. Question 25 has a space where you can draw or a space where you can type. You're certainly going to want a calculator for this part, but 0.4 times 2x is going to be 0.8x. And then 0.4 times 1/2 is going to be 0.2. Then I can type my equal sign, and 3 times 0.2 is 0.6x. And 3 times -2 is -6. Don't forget, though, that there's a -4 at the end. On my next line, I'm going to combine like terms on my right side. So I'm simply going to retype everything on the left. And 0.6x on the right, but -6 minus 4 is going to be -10. Now I'm going to subtract 0.6 from both sides, and I can write it like this if I'd like. Space, 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 space. Or I can skip that. Oops, I forgot my x. That's very important. Or I can skip that step if I'd like, and I could just write what happens when I subtract it, giving me 0.2x plus 0.2 equals -10. Now I'm going to subtract 0.2 from both sides, leaving me with 0.2x equals -10.2. And when I divide by -10.2 by 0.2, I get -51. Don't forget to type it in this box here. And that concludes homework 26.